This podcast is sponsored by ngrok. ngrok is the premier delivery platform for apps, APIs, and IoT devices for millions of users today. It provides the ability for developers to easily deploy their code by collapsing the complexity of the CDN, WAF, API gateway, and global network load balancing into a single SaaS service, while allowing CISOs and network operations teams to standardize their networking controls, auditing, and observability configuration for all network ingress in one place. If you are building a product that needs access to data, systems, APIs, or devices stuck behind a network firewall, check out ngrok.com today. And now, on to our show.
Can I get the icon in cornflower blue?
Hey everybody, welcome to episode 34 of Can I Get That Software in Blue? I'm one of your hosts, Chad Tyndall. Along with me is my co-host, you know him everybody, the artisan of AI, Steve Mazak. Welcome.
Thanks, Chad. Hey, everybody. It's good to be back recording a new episode.
Yeah, after our last episode was a live recording in New York City, you went straight from the recording studio to get on a helicopter to, take your G5 back to Phoenix? Is that what you did?
You're hilarious. No. So it turns out I learned when I was in New York that, an Uber to JFK is like $117 depending on when you go. And someone I know told me about this helicopter service called Blade. And I was like, I'm not taking a helicopter. That's got to be like thousands of dollars. Well, it's only $200. So it's really not that big of a deal. It's like accessible. So you go to the little station. It's on the west side of the island.
Yeah, we're on the Hudson River.
Yeah, on the Hudson. I think it's like in Midtown. And so you just hop on. There's like 4 seats in the back. They were all packed. It's very small. Like, I'm a big guy. I did not fit very well. And then 6 minutes later, you're at the airport at JFK getting on a bus that's going to take you to the entrance of the airport. So you still have to go through security like a regular person.
Oh, you don't clear security at the Blade terminal?
No, you still have to go.
That's terrible.
Yeah.
Like a peasant.
Yeah, it's cool. And like seeing the city from that perspective was awesome. It kind of made you feel like you're in a movie or something. But also, if you get motion sick or air sick, take a barf bag. It's 6 minutes, but oh my God. Like, I've never been on a helicopter. It's up and down, left and right. It's like, how do these things stay in the air?
6 minutes was enough. You almost threw up?
I didn't almost throw it, but I could tell, like, if I was on that thing for an extended period of time, I would have gotten sick.
Oh, that's a fun experience.
Glad I did it. Yeah, it was really cool. And it feels so bougie, like taking a helicopter.
The fact that it's not much more expensive than an Uber is pretty wild.
It's crazy to me.
That tells you how pricey Ubers are now. Mm-hmm. All right. Well,
or how subsidized helicopter fuel is. I don't know.
That's also true.
When Blade first started, it was only, if it was your first trip ever on Blade, it was only $99. So it was actually like cheaper or about the same price as a taxi.
I can't believe in this day and age, like, that's now accessible to the regular person. It's so cool.
Amazing. 6 minutes instead of an hour in traffic.
Dude, who needs flying cars when you have a helicopter? It's the same thing.
People who don't get sick, I guess. All right. Well, we have a special guest today from Elastic to Kong. He's soared above the rest. Now as head of product at Vectara. He's simply the best. Shane Connelly, welcome to the show.
Thanks, Chad. Great intro. Thanks.
Yeah, every time. You always get a custom intro.
That's part of the show.
That's part of the show. You get the fun of that. All right, Steve, take us away.
All right. So Shane, welcome to the show. You and I worked together at Elastic for many, many years, where you were head of product management for search. And we'll get into that in a little bit, but I kind of wanted to go back in time a little bit, get people to get to know you a bit. So can you tell us how you got into IT and, what attracted you to search initially after your, first experience in the technology world?
So my background's in electrical engineering and specifically sort of electromagnetics and antenna design, which is a very different world than software for the most part. But I remember in one of my sort of final courses in college, there's these non-parametric-ish antenna types where you're trying to vary the lengths of wires and stuff like this, and the electromagnetic radiation sort of differs by how long and the distance between them. This is called like a Yag-Yuda antenna, in case anybody wants to go.
Yag-Yuda. Oh, that's fascinating. I'm Googling right now.
Yeah, two people's names. And so it's a really interesting thing where the radiation output is not one that is known, but you kind of have to test for. And there's a suite of software, one called NEC. It's a numeric electromagnetic code that will sort of run these electromagnetic simulations on it, on your antenna design, and breaks things down to like the smallest differential and propagates a virtual signal through it at some frequency or frequencies. That was when I first started getting really into kind of like machine learning. I was for the class was whoever created the best propagation, the best antenna, got the best grade. And it went down from there. So you were highly, incentivized to create the best possible antenna design with the right widths and everything between it.
It's like those bridge building competitions that mechanical engineers have to do, but with antennas. That's crazy.
Not unlike that, yeah. And so that was when I first had started learning about genetic algorithms, actually.
Well, that's a big leap. How did you learn about genetic algorithms testing antennas?
It's an optimization technique.
Yeah, it was unrelated. I had a friend in a computer science class, and he had been working on some genetic algorithms and told me about them. It's like, this is really interesting, and if I apply this to this antenna design problem, then maybe I can farm out the sort of design of this antenna to all of my friends' laptops by getting them to run a genetic algorithm that would be varying the parameters and running this NEC code on my behalf, and then I just set up a server that would capture all of their responses basically and look for the best one and then reform out the best, of the children basically.
It's similar like what they do with SETI, where you can donate your computer time to the search for.
Exactly. So it was around the same time as SETI, was still pretty popular. I don't know if it is anymore or not, but that's part of where I got the idea as well. And it was really cool. I was like, this is something where, actually like a physical device, you can change and figure out the right things to do if you set up the right algorithms. So afterwards, I had an offer to actually work in SE. It was mostly called, sales engineering for a software company in San Francisco. And it was a software company that was based in search, and that some of their algorithms were actually designed on something called Shannon information theory, which largely actually came out of the antenna world, out of the electromagnetics world and radio frequency stuff.
So you came in through the hardware.
Yeah, so that's where I got started, was in sales engineering for a search company. Really wanted to move out to California to get my master's and actually just go off and do more antenna design, because I really did like that. I still like it, but it's hard to go back once you start making money.
Yeah, that's very true. Yeah, if it wasn't true, I'd probably be making pizzas in a pizzeria right now. Actually, I'd be on a boat. Let's be honest. I love boats. So Shane, you said you still do antenna design. Like, has antenna technology changed a lot in the last 15, 20 years?
I think, yeah. I mean, some of those things have just gotten a little bit more standardized. I think the hardest thing, or the most interesting thing that's really developed in the last 20 years has been 3D antennas that have been, now you can 3D print onto a circuit. Phones forced people to make some really drastic changes in terms of the antenna. So you no longer had the, walkie-talkie style, antenna that was...
Can you imagine if we had those on our phones to this day?
But that was the case, right? That was the case for so long. So trying to shrink and miniaturize things has really moved into creating really good antennas that are very small. So you would never kind of go through the same exercise that I went through then. But
so just for the listeners, and I'm curious about this too, was there some fundamental new discovery in antenna design that allowed them to create the smaller antennas in modern day phones? Or was it just like a series of little tiny things that led to what we have today?
There were a few. Matching the impedance, for example, is one of the things that you might want to do. And it used to be that you'd plug these little, if you've ever taken a really old radio apart, you might have seen these surface mount resistors and things like this. People started realizing that you could effectively create some impedance matching by adding traces on the PCB and nothing else, which was kind of cool. So you're just actually drawing out a little piece of metal on the circuit, and you can use that to actually do things like impedance matching. And then now people started going from 2-layer designs on the PCBs where you're just smashing two together. And now I don't know what they're up to, probably 10, 15 layers of PCBs. So you can start doing a lot more radical things when you're trying to go there. So
fascinating. I did not think we'd be talking about antenna technology this morning, but I'm glad we did. All right, so Shane, how do you move from that world in sales engineering to being a search PM? I mean, how can you kind of walk us through that journey a little bit?
Yeah, sure. So I started off, like I said, in sales engineering for another B2B search engine. I really loved working with customers, to solve their problems and really understand it. I imagine both of you as well. And, I tried a few other roles. I realized I really liked the sort of technical guts of search. So I tried actually briefly switching into software development for a little while, but I just don't like writing software and sitting in my, chair all day. And then I switched into professional services. In part, if you look at the 2010s, a lot of B2B software was getting oversold. I think we do a little bit less of this now with, things like solution architecture and somebody that might sit, and watch the end to end and field engineering, that tries to really make sure a customer is ultimately very successful in the long term was not quite as popular. People were signing much longer deals and just trying to get the money and run, basically. So I switched over to, professional services and really trying to help clients end to end, and ended up being kind of a forward deployed software architect where I was, helping our engineering team figure out what the APIs were that different customers really needed, how those should operate. And, there were a couple of years where I was traveling 200,000 miles or more. I'm sure that's not a story that's, one that's far afield from what you've experienced as well.
I never traveled as much as you did in a year. Like the most I did was 120. 200,000 sounds nightmarish.
That's a lot of international travel, I think, to get to 200 too.
I mean, there was like a client that we had that was in Nashville. I'm in the Bay Area, and I was flying weekly for them. The company was based in Cambridge, UK. So, I was flying out to Cambridge a few times. We had a few international deals as well. And so, yeah, I sort of realized I really like working with software developers to cut through the squeaky wheels. Everybody wants everything all the time, and really trying to understand what the market trends are. And I was very fortunate at the time that the company I was working for was acquired by HP. And HP had an internal program for some folks that had this type of role from other bits, where they would basically send you through product management and product marketing training for a multi-week course that was pretty intense. So I really learned the ropes there, which is, I think otherwise it's, at least at the time, I think this is still true, it's kind of hard to break into product management if you don't have an MBA, for example, and I did not.
Right on. So they trained you, and then I'm sure you didn't just like roll into it and were the greatest PM ever. You had to kind of cut your teeth on a lot of things. But what was the first product you looked after? Was it still search, the search aspect of HP? Yeah,
we produced this. I mean, it was the same product that I had been looking after before, called IDOL, which was a old enterprise, now legacy enterprise search product, and that has shifted hands several times. So I was working on the product management for IDOL. As part of the acquisition from HP, they brought in a number of folks from their printer division, which was kind of an odd setup, but some of them did have some software experience, and so I got some mentorship from them. But yeah, I was mostly leading the product management for that search engine, which I had a fair bit of long leash, I guess, in some ways, that we didn't otherwise have a product manager for. That software included speech to text, it included image recognition, and a few other things. So I got to touch a lot of things there. The only thing, I mean, I'll mention one other thing is I did start to realize after some time that I had worked for this smaller startup that ended up getting acquired. We got acquired by HP. It's this, at the time, I think 350,000 person behemoth. And, going through some of the exercises, for example, getting a roadmap approved by legal, and taking multiple weeks to months really made me realize I did not want to work for a really big company like that, or at least one that was not quite as nimble as I would like to be. And, I stayed there for a couple of years afterwards. I learned a lot, and I think it was a great experience, but decided that after that, I took off about a year and did two things. One is started another company and eventually sold off those assets, but mostly traveled during that time and really enjoyed myself. So, yeah.
Let's talk a little bit about the search aspects, like the deeper technology stuff. So when you were at HP, was the core technology, was it built on Lucene? Because Lucene's been around for multiple decades, or was it something completely proprietary?
Completely proprietary. Yeah. So this was Autonomy. Yeah. So as you mentioned, Lucene I think dates back to 1999 or so, when it was first created. And this company got its start a little bit later. And actually, a lot of the marketing speak that we were using for the product was, hey, we're using, instead of just using TF-IDF, which Lucene had been sort of pinned on for a long time, we have better relevance algorithms. And we talked about using Bayesian methods, which is more or less BM25, in the software. So yeah, it was completely proprietary engine. The storage was all completely proprietary data structures and everything else. Nothing was borrowed from Lucene. And
based on your experience from then up until now, do you feel like that engine was fairly advanced for its time, or was it kind of behind the times?
Yeah, I mean, definitely. So using something like Bayesian approaches for making sure that you have good relevance back in 2005 was wild. I mean, Lucene didn't make that switch to the default until 2015.
Oh, I didn't realize it took that long. Yeah, okay.
It might even be. I'd have to go back looking at the notes. It might even be closer to 2017 or 2018. So yeah.
One of the things that I know we've talked about previously, and this comes up a lot in search, is how you actually measure relevance. And I'm sure this will come up later as we start talking about AI and vector stuff. What are there common practices for the industry to measure how good an engine is at relevance and how good a tuned machine is?
Yes. Yes, there are. I mean, there are several sort of functions that are out there. So sometimes you'll see a number like precision at K or precision at 3 or precision at 10. Responses are within the first 1, 3, 10 results to make sure that that you're getting very good things. There's sort of a trade-off in the search world. There's something called precision. There's something called recall. The recall is that you want to make sure that you're getting all of the relevant results, and then the precision is to make sure those results that show up at the top are good, which are two sort of different sides of the coin, if you will. And so you'll talk about sometimes precision at N or precision at K, recall at N, recall at K or whatever, and then sometimes there are a couple other formula that you can use. So there's like NDCG and some that try to sort of combine the two of those together and potentially create like a list-wise pairing score. So there are ways of measuring it. Unfortunately, like it's super deep in the math side for most people, and most of the time when you're talking to a customer, it's like the CEO noticed a bad result in the third response for one specific query. So getting into that habit of having that is I think still not something that most people do.
With all the recent change we've seen in the search world with vector databases and generative AI, is there a need to update these relevance checking algorithms? Or is it just they work on the new stuff just like they did with the old?
The algorithms work as well on the new stuff as they do with the old. In fact, in some ways they work better because it means that you're like a lot of it's done using human labeling. Like somebody actually goes through and says this is a good result, this is a bad result. And in many of the cases, the old algorithms, like with keyword algorithms, people were kind of forced in some ways to pick whether it was answering a keyword question correctly or providing a relevant result to the question or whatever was being asked. So in some ways, the ones I just mentioned work better. I think the area that still is outstanding is how do you measure hallucinations on the generative side? And that's really a point that is very much in active research.
Is that something you can measure outside of a human just saying, hey, that's not real?
To some extent, yes. So there's some interesting benchmarks that have kind of gone around, and not to make this too politically charged, but like there are answers that are very difficult to actually say yes or no because it might depend on who you are. So an example that I saw recently in one of these benchmarks is Taiwan an independent country?
Oh yeah, ooh, talk about charged.
And like if it responds yes, is that a hallucination? If it responds no, is that a hallucination? It obviously depends very much on your background, your political leanings, and so on.
Well, especially in like a religious context too. If you ask it certain questions, you're going to get 3,000 different answers, right? Based on even just Christianity alone. So,
but it could answer. I mean, it could just give you factual answers, like Taiwan's not a member of the United Nations.
And that's where a lot of these things are coming out, is like they, you see the best scored ones as they have an independent government, and there's a lot of contention as to whether they should be considered an independent country or not, right? And that's not directly answering your question, right? But maybe that's for the best.
Well, I mean, we would just say the UN doesn't recognize them as an independent country. So anyway,
well, it's almost like I think we need some kind of universal way to measure the truth, which is going to be really, really hard to get to if possible at all. And then for this stuff, there has to be a way.
But Steve, what if truth is relative?
I mean, right now it kind of feels like it is.
One of the things that we're really focused on is rather than trying to create a generative system that attempts to answer those types of questions, like those are, I think that at least for the time being, those are going to be fraught with failure. It's going to be really hard to come up with something that is truly universal truth. And so the sort of emerging architecture that a lot of these generative systems on generative text are talking about anyway is what's called retrieval augmented generation, or you sometimes see the abbreviation RAG thrown around, which is, hey, I'm not going to try to craft an answer from just the large language model. Instead, I'm going to perform a search, which is how I've gotten into this. Perform a search on the information that is contained within some sort of index or corpus and use that as the basis for the answer. And I'm only going to use the large language model to actually craft the text or to reinterpret the text that has come back from retrieval. And that's where we're sort of focused on, is that still in some cases hallucinating or not, if that makes sense.
That does make sense. All right, I want to talk more about this, but let's go a little bit back to the history of search and talk about kind of how we got here. So Shane, the way that Lucene works under the covers is TF-IDF. For those of you, the folks on listening or watching that don't understand what that is, can you describe that a little bit?
Yeah, so a slight correction. Lucene is largely using BM25 at this point, not TF-IDF.
And that switch was like 2015, like you said.
Yeah, somewhere around there. I mean, the same though, just in terms of the general things that it's keeping track of. And so I think the simplest explanation is go look at the back of a reference book, and you will find that there's a set of words or whatever that are in the reference section alongside a set of numbers or pages that are often associated with that. And that is called the inverted index that is often used. And then TF-IDF or BM25 try to take into account kind of two things. One is how often a word shows up in general in a corpus. So like the word "the" shows up in every English document pretty much, or "a" or some of these others. The way that BM25 tries to adjust for that is downgrading words that show up very, very frequently. And that is the IDF part. I mean, IDF is used in both TF-IDF and in BM25. And then there's a second part that tries to look for the overlap of the words, the keywords that you're searching for alongside the words that show up inside the index to produce, like, if somebody is using more of the same keywords and more times, in general, that document will get ranked higher. And there's, obviously an algorithm that goes behind that.
So these algorithms work pretty well, but they're not enough to get you the best possible search results for your user experience. If they were good enough, there probably wouldn't be relevancy teams around the world. What do people have to do to tune that relevancy from the base algorithm to where it's considered good? Like, can you give us some examples?
Yeah, so there's a lot, and part of the reason why these large language models and embedding models and vector databases have become so popular is because they let you sidestep a lot of these things. So an example of, I'm just looking around my desk here. So I might call this a cup, or you might call it a glass. Those don't have any keyword overlap between the two. And so trying to, sort of semantically relate those two things together means that I have to now set up synonyms. And if I search for cups, should it match cup? And the answer to most people is, yeah, it probably should. And so you have things like stemming, and every language is different, right? And in Chinese, there's no spaces between words. So you need to come up with some sort of mechanism to ingest the keywords by splitting these characters in some sort of arbitrary stream. And many languages like Turkic have hugely compounded words where there's actually many different sort of concepts within them.
Like German.
German is a little bit like that. Turkish is worse.
Oh, I didn't know.
Yeah. So there's like the longest Turkish word is like 280 characters long.
Oh my goodness.
Crazy. So
can't even tweet it.
So you have to come up with specific algorithms that do each of these things that's very language specific. And then you need to come up with, again, things like synonyms and so on. And sometimes synonyms actually are very difficult to understand. The word "it" in English, that it's written as IT, but IT also has potentially the meaning of information technology, and it potentially has many other different meanings to it as well. It could mean the movie "It," and actually even trying to place each of those conceptually in terms of what the user might be searching for requires potentially understanding the context of the other bits of the text that they're searching for. And keyword systems just generally don't handle that, or they'll do things like adding phrase search and all these other things that are kind of proxies for doing that, but they don't work all that well for a lot of these problems.
The idea with vectors and this meaning or searching for meaning, like, you don't have to do stemming, you don't have to do synonyms, or do you still have to do some of that stuff on the edges, or is it just like those are no longer issues? So I'm trying to understand, like, is it just you don't need them anymore, or you only now need them in specialized circumstances?
So you're getting to actually a really interesting point that I'm going to answer slightly different. If you're operating a pure embedding model, that those generally you still do need to take into some segmentation, for example, to understand where the words and phrases sort of end potentially. And you'll see things like word to vec or sentence to vec or paragraph to vec, for example, that tried to do some of these like vector embedding things, and that was trying to understand where the particular boundaries were. So if you're operating in a pure vector basis, then generally a lot of those things are handled for you. But what I think the industry has largely learned over a while is while vector these sort of large language models or embedding models can do very well at well understood data, they operate less well on things that never showed up in the training data. So things like names and product IDs and these sorts of things, like there's no chance that, Steve, as famous as you are, that somebody searched for Mazak and is going to get a good result out of a pure embedding model, because it's just not going to have shown up in the training data often enough to show up. So what we found, and what I think most of the industry is leaning towards, is that you do need to have both a semantic sort of large language model based system alongside a keyword to handle where each of them is very good at. But then you get into this like multi-system management, and you need to blend the results correctly and these sorts of things. So you still do need it, but mostly on very unusual words and that would have never shown up in the training data, or product IDs and those sort of things.
Let's back up a little bit. We might reverse this in the recording, we'll see, but let's talk about a bit of your PM experience at Elastic. So you join that organization and you're going to be dealing with an open source project and then all of the other stuff that Elastic added around Lucene. Like, what was that like, managing an open source project and the internal stuff as a PM?
Well, they were both open source. It's actually, you got the open source Lucene stuff, then you got the Elasticsearch open source stuff, then you got whatever proprietary stuff on top of that, XPack, whatever.
Yeah, I mean, it was, I'd be lying if I said that, I was the primary driver even on like a lot of the Lucene stuff. I think, you really have to acknowledge that it's a big community and people that have vested interest in many different products. It's not just Elastic. It was, Solar, IBM was involved. There's all these different products that were built on top of Lucene, and they had set up a project management committee around it. And so we were very fortunate to have software engineers like Adrian Grand and like Mike McCandless that were both excellent sort of PMC members and very personable and understood the business as well, so that we could work collaboratively on how we wanted to get Lucene to adopt some of the things that we really needed to move the product forward. And so, for me, it always starts off with what are the end user effects that we'd really like to achieve, and then you start working backwards from there, right? Like, we want to do this in the least hacky way possible, and in general that's going to be trying to do it in Lucene as much as possible. But there are some times when the Lucene committee was just completely averse to adding something, and you might need to come up with an alternative strategy for doing that, and that's where you saw some things like adding something into Elasticsearch only, or in occasions when we were able to commit some things into like an experimental branch inside of Lucene and then make use of that. So there's a lot of these sort of strategies depending on the particular of the feature that we wanted to release.
Well, what's an example of something that the Lucene community didn't want that Elasticsearch wanted?
Oh, I mean, for example, I think so actually BM25 is a great example, right? The product is 1999 is when it was invented. BM25 was invented in the late 80s, early 90s. But what we saw a lot of times was, switching from TF-IDF to BM25 would have been considered a breaking change. And so we had to manage this process with Lucene where they were on a 3-year long breaking change cycle, and, trying to get something like BM25 switched to the default was a rather lengthy process, because there was just so much uncertainty across the community. Is this going to be good in all use cases? Well, no. There's some occasions where TF-IDF is better. Is it worth making the breaking change? We saw a lot of this with the numeric stuff that we added into Elasticsearch as well, where we had to go through phased approaches where we were adding some bits only into Elasticsearch, and then we were able to get some things added to an experimental branch inside of Lucene, and eventually that has become sort of the de facto. So,
well, is that just because of this issue of breaking changes? Or were there other things where they were just like, oh, no, we don't want to do that for philosophical reasons or something?
There were some that were philosophical. So, for example, and to their credit, I think some of these philosophies have changed. But, for example, Lucene for a long time was an independent project, and then they pulled Solar into the project. And Solar does some of the same things that Elasticsearch does. It handles things like replication. It adds, an API, a RESTful API endpoint to the end of it. And so there were some things that Lucene would not accept unless you also solved the problem for solar, for example, which was obviously not our business. And so there were times when we had to sort of do things like that and sort of work around them or decide whether we wanted to commit one place or the other. Now, that decision has ultimately been reversed, and solar is now, again, an independent project of Lucene relative to Lucene. But that was an example of one that was like not a breaking change related one, but due to sort of a architecture of the project. And there were others that were around, what about the performance implications of this? What happens if a user uses this feature wrong? And we knew inside of Elasticsearch we were not going to be using it wrong. But I think it's a valid point of like, what happens if somebody inside of the community gets harmed by the change that you're trying to push forward in some other fashion?
Why would Elastic care whether BM25 was the default? Can't they just use it anyway, even though it's not the default? Like, why does it matter?
Yeah, we could, and we did. Right. So in some cases, yes, you absolutely can. And it comes down to like, how much code are we maintaining inside of something like Elasticsearch relative to Lucene when we felt like it was generally the better move for everyone? You're incurring effectively, technical debt by adding patches on your side that you have to maintain over long periods of time.
Yeah, it's always better to push it upstream. Yeah,
as much as possible.
Hey, Chad, there's a link I just added to our docs for the show notes, but Elastic has a whole history of Lucene page on their website that's very long. It's really cool, actually. It starts with Doug and Doug cutting the guy that created it and goes all the way through it. So
okay, I haven't seen this page before.
Yeah, it's pretty sweet, actually.
It was right around I think we started working on that for the 20th anniversary of Lucene.
Yeah, it was the 20th anniversary.
And there's a really nice video that associated with that as well on YouTube.
All right, so Shane, we can't turn this into a Lucene training podcast, unfortunately, but it is kind of becoming a search training one. So let's talk about the move on from Elastic to Vectara. And I know you worked at Kong in the meantime, and maybe we should talk about that actually. Like, what pulled you to Kong? What was the excitement there?
It was two things. One, it was, again, Elastic had gotten to a size that I wasn't certain that I was going to learn as much as I could for the next couple of years. Whereas Kong was, again, 100-ish person company and a little bit more opportunity to shift into another developer tool area, but not exactly the same, and work on another open source project, another open core project. And I was, felt like I could bring some of my expertise in there, but it would still be enough of a new learning in a new technology. That was very exciting.
And you were the head of product management for all of Kong, or just a specific suite of functionality?
I led the product management for their sort of flagship gateway product. So the API gateway, and then the Kubernetes ingress controller as well. So
how different was that going into Kong versus Elastic, knowing that you had to, manage all these open source projects? I'm sure it kind of set you up to know what to do there, but it couldn't have been exactly the same.
Very different. And so different types of personalities than what Elastic had, for one. Very different go-to-market as well. Elastic struggled, a bit with the sort of top-down, trying to sell into enterprise leaders, whereas Kong was very good at that and less good at like the PLG side. And so, it was a lot of, where can I bring my expertise in there, and what can I learn about the existing motion from a better established top-down organization. So, do
you feel like the ecosystem that Kong is in, is that like one that's growing rapidly, or do you feel like it's kind of topped out a little bit?
That's a good question. I mean, it is. I mean, there is a little bit of commoditization in some ways of API gateways in general. I still think that there's a long opportunity for advancements. I mean, it's like asking, are APIs going to increase or decrease? I mean, I think they're going to continue to grow for a long time, and people are going to need the tooling to help them manage those APIs. And if anything, I think we've learned a lot about the risks of not having products like Kong, but really on any API gateway inside your product suite.
In terms of top-down enterprise selling, any nuggets of information that you can pass along here that you hadn't learned at the open source bottoms-up model?
I don't know. Definitely a very different approach to working with organizations. So, whereas at Elastic, we often sort of worked our way up. We found some sort of software developer. We tried to convince them and their team to use the product by having a really great product. They tried to convince their management, and we ultimately, sold into often smaller BUs and sort of worked our way up. They were very good at finding a CTO or a CIO and saying, hey, you probably have a lot of APIs in your organization, And these are the risks of not trying to do something like this. And maybe that's a good investment for you to make. And so it accelerated in some ways it accelerated large deals, and in other ways you run back into a little bit of the problem where you have a software developer that might not have been bought into the software at the time that it was being sold into the company. So
I imagine the post-sales motion that you go through is a bit different in a company like Gong, because you're now trying to convince the developers to use it and use it the right way.
Exactly. It's very much, how do you convince them to use it and use it the right way so that the project's not going to fail and the CIOs or whoever is going to look bad in a year or two from buying this. So it's a lot of that. It's also a little bit more upfront commitments that we were going to add features, for example, into the product in order to really convince a CIO that it was definitely that we were going to be a good partner with them, and very specific ones in some cases.
Right on. So let's talk about your move to Vectara. So I don't think it's lost on anyone that there's this new data world emerging with vector databases and generative AI and all of these things. So let's talk a little bit about kind of, Shane, from your perspective, what you saw that made you think, okay, I need to get into this space now or eventually, and then kind of how that led you to Vectara.
Yeah, and you joined Vectara before ChatGPT came out, right? It wasn't like, oh, this is a huge space, I better go get in it.
So, a lot of it goes back to some of the, when you are working in a company like Elastic, you're exposed to very interesting users that in some cases are very advanced in their usage. And you start taking these cues of like, this is definitely where the market's going to go eventually for this thing. And back in 2018, there was this seminal paper released, a series of them from Google. The first one being this thing called Attention is All You Need. And then, this sort of introduction of a large language model called BERT. And we started getting a lot of questions from some of these users that you just know, these folks are really staying on top of it. This is going to be the direction of search in the future. How do I integrate BERT into Elasticsearch? Now, that was the wrong question to ask for those users, really. But the real question that they should have been asking is, Elasticsearch doesn't handle vector storage and approximate nearest neighbor search very well. How can we handle something like that? And that would have been a much more interesting question to be asking. But transformers, for sure, 2018, became very obvious. And it became obvious to me that, like, from Elastic's perspective, the full text search world was just a tiny drop in the bucket relative to the observability world, and it was going to be very difficult to get investments inside the business on full text search that was so new and so different than anything else that had come up before. So that's where I really first started learning about transformers. Yeah, it was 2018 when some of these users were talking about it, and was immediately obvious to me like how much time and money could be saved by not having teams of folks manage synonyms and zero hit queries and all the rest of the stuff that I've seen search teams struggle with.
What made you pick Vectara? Because there's multiple vendors out there, right? And they all started kind of before ChatGPT became a thing.
So there was an option to potentially move to actually disambiguate here for a second that Vectara is not a vector database. We have a vector database, but we are not a vector database. And that was a choice that I was trying to make, was do I move to somewhere that is going to be a vector database, or should I go somewhere that's going to build the Mac of, semantic search, which is, hey, I don't get to pick my exact CPU. I don't get to pick like every little bit. They have chosen the things that are going to be most optimal for me. And so
how, just look, maybe give us the 30-second plug on what Vectara actually is then, because I thought it was a vector database company too.
Yeah, so Vectara is an all-in-one, batteries included, end-to-end system that will do everything that you need to launch a semantic search and generative text application. So we do everything from, you can upload a PDF and we'll extract the text out of the PDF. We'll do all the chunking for you. This is something that a vector database often doesn't do, is try to do the chunking.
What does that mean?
Trying to figure out like the boundaries for appropriate semantic meanings, basically, to build the vectors on top of.
It's like, where does context begin and end for a certain thing? Exactly.
So we're doing the chunking for you. We have launched our own large language or embedding model that we've built from, in-house, that outperforms the other embedding model companies, like it outperforms Cohere. And then we index that content both into a vector database and into a keyword system. And then when you perform a search, we do all of the rest of the things on the other side that you would need to do to build a system up that uses this. We will automatically find the results from both the keyword and the vector system. We'll automatically blend those two results together for you, so you don't need to deal with the blending. We will automatically deal with the highlighting of any results, including semantic highlighting instead of just keyword-based highlighting. We'll automatically go off and produce the generative summary, and that generative summary will actually be able to do this retrieval augmented generation and cite its sources. So it'll say like, Taiwan is not a country as referenced by the following, document. And this helps us get us out of that, what we talked about before. Or it is because the following document has that information in it.
So the AI model has explainability into it.
Exactly, yes. So that's the full end-to-end, basically.
From a search point of view, Vectara is more competitive with like Elastic then, in that sense.
Yeah, it's more like a semantic-based Elastic or Algolia, if you will, SaaS model.
And the way that you guys talk about it is like it's built for developers and PMs so that they can integrate it into their products and then go to market. So do you have any exciting use cases to talk about, Shane, that are, we could talk about a chat one, but those are kind of played out in my mind. It's just, I know people are building them, but it's the obvious one. And then the other one is, like you said, like getting information, like a tribal knowledge database type of thing built up. But what else are people building on top of Vectara and these generative AI systems that we might not think of as an obvious thing?
Yeah, so definitely chatbots. Definitely some, we do have customers that are just using us for just the semantic search and not for the generative side. I think it still makes sense there are some cases where, actually a lot of cases where folks are not quite ready to make the leap into a generative system producing, full text response. But we also have, I think some of the most interesting ones are around sort of research and analysis. Those are some of the more interesting customers for us, because one of the very interesting side effects of the way that we have built our embedding model is you can perform a search in one language and get results back in a different language. And it's not using translation.
Yeah, I read that on the website. You guys support like more languages than anybody else, I think.
Yeah. So you can perform a search in German and get back a result that was written in Japanese. And we're not using translation for any of that, for example. It's just by virtue of the way that the vector embeddings sort of work out. And that presents a really powerful opportunity for somebody that's trying to do something like research and analysis, where maybe you have, your team of chemotherapy researchers in Japan and a team, producing Japanese research documents, and a team of cardiothoracic or some other form of medicine in Germany, and they're producing documents in English or German. And the discoverability of that information has so far been hidden in many of those organizations, because asking someone to perform keyword searches in 25 different languages that they each have research arms in can be really tricky. Asking your Japanese, employees to start writing all of their research in English can also be tricky. And so we've seen a sort of really good use case around that, as well as processing user reviews that could be in many different languages, and this sort of like marketplace content in many cases when there's lots of different languages and users.
So it's almost like the universal translator for R&D. That's kind of interesting.
We've seen a lot of success in that.
Yeah, it could accelerate like product development and things, innovation, I think.
It also helps, I think, especially like in the medical case where, we heard this from one of our customers, that something like a doctor might type a note that somebody had a cardiac event, and another person might write, hey, this person had a heart attack. And, another person might write, whoever, like there's a million different terms for something that might be an adverse cardiac event, for a patient that is going through some sort of clinical trial or whatever else. And again, that's an area where keyword search systems just don't work very well. You have to type in all of the combinatorics of each of those things together. Or if the system really understands the semantics, it can obviously, maybe not obviously, but can figure out all of the relative keywords and semantic meanings that would relate to it.
You touched again on like a little bit about the concept of labeling, and made me think of the source of data for your guys' LLM. Like, where are you sourcing all your data from for the one that you provide?
That's a secret, Steve. Yeah. So the one thing that we don't do explicitly is we do not train on our customers' data. So there are some companies that will do something like training or fine tuning on their customers' data. And we've heard many people be very afraid. Like in some cases, there's some good opportunities, but fine tuning will actually improve. And we might eventually offer like a fine tuned personal model for just you, but we don't try to trade our generic models on customer data. we have, for everybody basically in the area, it's an arms race to try and get as much data as you possibly can to train your models on. That is the part of the secret sauce, so we can't talk about all of it.
No, that's fair. It feels like there's going to be some point of diminishing returns on the costs. Like you only need so much data to have a pretty good result that's not worth, spending more money on.
Yeah, what we're starting to see is, so we do what's called zero-shot large language models, which try to understand as much of the human language and context around the human language and different types of industries and verticals as possible. I will say, I agree. I think that they're limiting returns if the data is very generic that you're trying to search. But there's still a huge opportunity for gathering contract data. These sort of things that are often very private, for example, but would make fantastic input data, and the LLMs still do have a lot of opportunity to learn about some of these areas that are not perfect yet.
I assume that all of these various vector databases and LLM tools and things, as well as what Vectara is doing, were sort of all predicated on the idea that customers would want to fine tune their model with their private, enterprise private data. So I'm surprised to hear you say that hasn't been that important yet, or that you focused on other things.
So two things. One is a question of, is it actually necessary or not? And again, if you have a well-tuned large language model that's able to do most of the heavy lifting around language, then what tends to remain is hyper-specific terminology. And that's why having a combined hybrid sort of keyword plus large language model or vector system actually achieves most of what many people need for when they might ask about fine tuning. Not everything, but in many cases it does tackle most of those together. And then second, the world is so new, and many of these companies that are operating vector embeddings, like they don't have certifications on many things, and they know that it's an arms race. So there has been a fear from companies to say, if I give you this data and you train on it, and then that training data ends up going into a competitor, that's a huge loss potentially of very valuable business data.
Do you think that means that people are going to hesitate to move to cloud, or there's going to be new certifications or something like that proves that you don't do it?
We just got our SOC 2 certification. And so this is like one of those things that many companies in the space are still pretty new, and it takes a while to go through some of these different certifications. And that is part of what we're saying, is we're willing to put it in writing and then have a third party go through and verify that we are not, training on your data and not distributing that then externally. And I think it's absolutely going to be necessary. We have seen some aversion to SaaS, but I think there's kind of a more macro thing going on there than something specific to LLMs.
It feels like it's bad timing. Like, this is just a feeling I have, is that trust amongst the regular people in corporations is not at an all-time high. It's not even close. And I think it's partly because, the media has been exposed now for being very in the pocket of whoever they're in the pocket of. And I just wonder if that's going to hurt this growth for a little while. It's just the lack of trust. And that means people are going to have to try it on their own, and they're going to want to do all this stuff on their own before they either give up or realize that it's just going to be that much more cost effective to go and run it on a vendor, right?
That is our number one customer right now, is the person that tries and fails. Like, as unfortunate as that is, I think there's a combination of people that do believe it's easier, or easy enough anyway. And then they start looking at, I think Andreessen put out this architecture diagram a little bit ago, and it has like 14 different boxes in it. And, I think people are starting to realize, do you want to set up 14 boxes, and is your CIO going to sign off on all those 14 different boxes? You might get a part of the way there. It is pretty easy to go to Hugging Face, find a model that's popular, drop it onto Pinecone, or your favorite Milvus, or whatever your favorite vector database is, run some kind of search, and you'll get something out.
Numbers.
It's very difficult then to actually turn that into a working product.
I mean, it's funny because a lot of these vector databases that are so new, they just give you back numbers, and you need all this extra stuff to turn it back into something that actually means something, to your point. So,
and when you asked about why I was thinking about, Vectara specifically, it was because of an opportunity to build that entire platform instead of just working on something that was going to do the embeddings or the vector database.
I saw on LinkedIn that it's Amar's birthday today. Happy birthday, Amar.
I'll send him a.
Who is Amr, Chad? Just so the
Oh, the founder, CEO of Vectara. He was one of the He was a founding CTO of Cloudera, so I know him from way back then.
So Shane, you guys announced a couple weeks ago this thing called Boomerang, but no offense to marketing, but they're using a lot of the same words that a lot of other people use. Like, what is Boomerang and why is it important for Vectara and for the industry?
Boomerang is our model. Okay. So as we often say, in software, like garbage in, garbage out, if you're doing a retrieval augmented generation, the very first word there, the retrieval part, is incredibly important, because if you are retrieving the wrong set of documents, the generative side is going to not perform well, because you're taking those in and you're saying, summarize these or formulate those into an answer or whatever else. And so Boomerang is our model, and it basically is an embedding model. It converts that text into a series of numbers. And as a result of that, we have what we think is, and have had independent validation on, probably the best retrieval out there, so that the generative side is able to act on the best information.
So Vectara is not as well known potentially as like the Facebook or the Meta model, and the one from OpenAI and all these other ones. Like, how are you guys going to stand out? Or does it really matter because you're serving a different audience?
So, I mean, we did think through, what's the packaging model basically, and where are we going to do deployments? And, there are a variety of options. One is release it on Hugging Face, for example, and make it a model that anybody could run. And in some ways, we felt like that would undermine the statement that we believe is true, that you kind of do need to have a full end-to-end solution to really build a good product. And, it's not fun releasing something and then see somebody struggle with it, know why they're struggling with it, and say, like, the actual solution is that you should not be using this model yourself. Like, that's not a very good experience. So we ultimately decided to release it only on our platform. We think it's a competitive differentiator for Vectara's SaaS platform. For now, we might eventually change our mind on that, but for now it's only there, and that's largely why.
Do you feel like that's going to be kind of the experience that most people have as they go and they try something on their own, and then it comes time to actually build a real product for their company or whatever, and they're going to have to use something off the shelf? Or do you think people are actually trying to build production systems and failing, and then they're moving to Vectaras of the world?
We have definitely seen that happen. And I think if you're trying to build something, like, there's like increasing levels of complexity, right? One is, you don't need a search system at all. You could just pump a billion documents into Llama 2, or however many you have, into Llama 2 or into ChatGPT. Now, that will work up until a certain point. Like, many people start noticing, hey, my results take 50 seconds to generate a summary, or 100 seconds, and it's because the context window, the amount of stuff you're feeding into the generative model, is so large that it takes a really long time to return a response. And so I don't think computers will get faster, so that's not a doubt of mine. But that pattern is going to be really tricky for operating larger numbers of documents. If you have an FAQ set of 100 documents or something, it probably works fine, and probably always will. But as you get into these larger enterprise use cases where there's maybe thousands of documents or hundreds of thousands, we've run into several customers that have tried that same approach and seen their performance is just awful. They start blaming embedding models or large language models in general as like causing the problem. Whereas I think if you flip the problem on your head a little bit and say you really should be doing retrieval, actually, I say this, we have like 4 different large language models embedded inside of Vectara for different purposes. And I think going down the path of like a single large language model for everything is part of the problem that people are still learning about. And
to your point, I think we all know, at least we know on the pod, like speed equals engagement. So 50-second search result, not going to work. It's just not, especially nowadays. People's expectations have moved into milliseconds. So
how are you guys thinking about the SaaS versus on-prem question? Like, your SaaS now, are you having people wanting to use it on-prem? Or are you just not seeing that to be much of an issue?
We certainly had a lot more of it before we were SOC 2 compliant. I think some of these are trade-offs between how you're going about your business, what certifications you're getting. There are still some customers and prospects that we're talking to that, would prefer on-prem or a split control plane data plane system. And, I personally think we'll eventually be forced into doing that. But as like a product manager, it's like one of the last things you want to do for a couple different reasons. Like, I mean, many people drastically underestimate the amount of maintenance you have to incur the instant the software leaves your firewall. Like, it will slow down your engineering team by most estimates 60 to 90%. And do you want to produce software 60 to 90% slower? The obvious answer is no. You should not want to do that. And most people say, well, what if we do the following things to try and cut back that loss to maybe only 10, 20%? And most of them don't really work, because the instant the software's left your firewall, you will see a slowdown. So that's the problem. And right now we're still at, a small enough company that we can make these sort of decisions. But, eventually we'll get pushed into doing something like that, I'm sure. And it'll be a very sad day indeed when we have to. But, I understand it is ultimately about meeting the customer what they need.
So Shane, I'm curious to hear something about the future. Like, has anything surprised you as to what customers are doing, or some conversations you've had and like just brainstorming on other possible use cases for generative AI?
So future on generative, there's two futures that I think are very interesting to talk about. One is actually on the embedding side, and one is on the generative side. And on the generative side, to answer your question directly, I think the most interesting set of things that's likely to come up in the next several years is, we've seen all these chatbots, like you mentioned. We haven't seen too many people building out systems that can start to take action on your behalf. Although I think that is the next direction that many of these are going to go. Like, if I can type into my HR system, hey, I need to take a vacation, next Thursday, or for 2 weeks, and it can go off and do the rest of like set my calendar, decline my meetings, go through and respond with my out of office, and like basically have all these plugs into different bits of software. That is something that a generative system could do very well with the right plumbing to get you there. And that's one thing that is pretty unexplored that we started hearing from some customers and users.
It's like the true assistant use case, basically. It's like
the true assistant, but also like assistant that's a little bit more personalized to your business. So like, one thing that I've thought about is, I've actually built one up internally using Vectara, RFI and RFP answering. I know you guys have probably done a million of these things.
It's a nightmare. It's the worst thing you have to do in this job. Yeah, it's terrible.
But it comes with the territory, because and the reason it's a nightmare for those that are watching this or listening to this that are unfamiliar is like, everybody asks the question in a slightly different way. And they might break out into 15 different responses or 15 different questions, or they might just like group all of them into one. It might have implications on other bits of the questionnaire and so on. So this is like an opportunity where fill out this RFP for me with all of the answers that you know.
People will pay for that.
Right. And do it in a way that is taking the information out of the retrieval side. So you're not just making things up that the LLM would have otherwise known, but actually taking it from your business, and it's taking action on a document. As a product manager, summarize all of the requests that have come in through our forums and start just filing the JIRA tickets for me. It's busy work, right? That all of us have to do, and it's part of the job, but it would be so much faster to have somebody take that action on my behalf.
Like, hey, I just traveled somewhere. That I took pictures of all my receipts. Go fill out my expense report for me. That's what I want, the expense bot.
I think from a LLM perspective, we're actually very much in sight of having that type of capability. And I do think they're going to be sort of like application specific use cases and these sort of things. We'll break them down. But there's nothing at this point like technologically stopping us, except for making sure that you have the right plumbing basically in place, and that you're, being conservative in some cases with like, don't submit a $1 million receipt when you're not 100% sure from Steve's receipt where the comma is or whatever. So,
well, I think you hit on it, is like the accuracy part is going to take years and years and years for the software to get it to the point where it starts building trust psychologically in us that we now will do these things with it. I think that's part of it. Like, I noticed in my own use of ChatGPT, for example, I stopped using it nearly as often as I was, because a lot of the answers coming back for the more advanced questions just weren't right. That's going to be a challenge, I think, for a while until we all figure it out.
Well, they're still working on corpus from 2 years ago. That's a big problem. Like, I was asking a question last night. It's like, as of 2022. Like, I don't have any information on that. Like, well, Jesus, 2023 is almost over. What are you doing here?
Well, that's another thing, Chad, is like the truth changes over time. And we haven't really talked about how we're going to deal with that in these LLMs because, the earth was flat and then it was round. So
that is, again, another one of the benefit statements that we see and we promote as part of retrieval augmented generation. Ours doesn't need to know, like, we don't have to retrain our large language model every 6 months based on the latest Wikipedia data if it actually only matters to your business. If you're asking a question like, what is the RFP answer to, do you have SOC 2 compliance? If you ask ChatGPT that, it's going to give you nonsense answers because it doesn't know. But if I feed it with the right information for your business, it doesn't need to know anything about it might need to know a little bit about the current date to act in certain ways. But I think there's a huge opportunity for not needing that information. The other side was I was going to say the embedding model, but
yeah, go ahead. Let's talk about the embedding model, and I have another question.
Yeah, on the embedding model, I think the one that's interesting is we talk a lot about like sparse versus dense models, where sparse is like the traditional keyword stuff, and dense is this very dense vector embedding. There's now starting to be some pretty interesting research that maybe you can combine those together. And there might be some good opportunity to do that into a single vector representation. So I think we're still a couple years away from having something that does both of those things realistically really well. But it's not like the fact that we have deployed hybrid keyword plus vector might not actually be the right deployment in 2 or 3 years.
You bring up another thought and the question, Shane, is like the academic world and the commercial world are very close together on AI right now. It seems like we're closer with the academic world than I've ever seen in my career. So there's a lot of research that's still coming out. You mentioned even more that's happening. Do you feel like it's a little too early for companies like Vectara to see explosive growth, and you think we're going to go through this kind of building phase and before it hockey sticks up as far as adoption?
I don't think it has to do with that. I think the hockey stick growth opportunity right now is, my opinion, more macro related, actually macroeconomic. Right now, we are still in a recession in many places. Interest rates are still very high in many places. It is difficult to get a CFO to sign a check for a reasonable amount on something that's not going to change the bottom line. And many of these investments are basically, how do you invest in net new technology that might be completely game-changing, but also might run a risk to your business and signing that check. That is what I see as the bigger challenge right now with growth of many of these systems. But I think we're nearing the tail end of that, and there's going to be an opportunity for a lot of these systems to grow pretty rapidly after that.
Well, it could be a confluence of events that lead companies to adopt these technologies where we can prove that it saves exponentially more dollars because maybe it's not replacing humans now, but it's preventing you from having to hire the next 100 people, right? Because now you can use the software to do some of these jobs.
I mean, that's the right messaging for right now, of course.
Well, I'm in sales, so
when you go talk to an IC and say, the value proposition of the software is that we're going to reduce headcount, is, that's, you do get back into some PR stuff.
No, I know that when I talk to software leaders, like over my career, they've always said the best way to do it is like, I can help you not have to hire the next 10 people.
For me, it's like, again, I can help you not fill out RFPs.
That's right. It's right? Appealing to a lot of people, I think.
Which is pretty attractive. But I mean, I do think there are some other things that are kind of going on in LLMs specifically, like when you're opening up ChatGPT and you're greeted with this giant gray-black box and it's just asking you a single question. That's not the UI of the future of generative AI. Right? That is just such a simplistic view. I think there is a lot of opportunity for the development of UI and UX flows that ultimately make this a more meaningful experience for both companies and their users. I do think that is also holding people back to some extent from deploying these.
So Shane, I think this will be my last question is like, let's talk about what's preventing adoption other than some of the stuff we have talked about. Specifically, I want to talk about like the cost of a query and how we all know that it's very expensive to use these LLMs right now. The GPU manufacturers are building more GPUs than we've probably ever seen in our history. Like, what do you think is going to have to happen to get the cost down to make these things more approachable and more scalable? Because they can scale technologically, but like cost-wise, It's expensive.
Let's talk about what the cost actually is, because Friedberg, who used to work at Google, said on the LN Pod that the cost of a Google search is like 2.5 cents. So every time you search something on Google, it costs Google about 2.5 cents to run that search. When you amortize in everything, right? The cost of the data center, electricity, cooling, servers, people, everything. And it's about 10x that for a chat, like an OpenAI. Every time you query something in ChatGPT, it costs them about 25 to 30 cents. So is that kind of accurate? Is that true in a Vectara type model as well, or what does it look like?
I mean, I have no doubt, or I have no reason to not believe somebody that has run that accurate of a number on their own systems. I can say it's not accurate for us though. And so, we offer, so Vectara, we do have a free offering. We offer 15,000 queries plus generative summaries every month for free. And we are not losing that much money as what you just described per user on a free offering. And part of this again is I think it does come down to,
well, is that just because your model doesn't have 125 billion parameters it has to evaluate in parallel on so many GPUs, and it's just more efficient?
No, so I can say that right now our generative model actually is ChatGPT. So we're not at a particular advantage or disadvantage. Now we'll be self-hosting a generative model here shortly, but that is not the cost. Like, again, if you flip this problem on its head and you say, well, if I'm going to have to feed this enormous context window of 10,000 tokens into ChatGPT, the way that they price is by tokens in and tokens out. And tokens in is usually like, you consider a token is roughly 3/4 of a word. And that many tokens, if you're trying to submit an absolutely enormous set in and tell ChatGPT to respond with something, your costs are going to be really high. But if you flip the problem and you say, embedding models are actually much cheaper to operate. And so if you first get the vector embeddings out, you perform a query using the vector embeddings plus keyword, that's generally a pretty cheap operation, like relative to the generative side. And so you can start collecting the relevant results, make sure that it's really, really good, high quality stuff, as opposed to just submitting, the kitchen sink to the generative side. And so we're able to significantly trim down our costs for a per user query per summary generation by really trying to make sure that we are not trying to follow the same architecture paradigm that many people are failing at and finding enormous query costs on.
So you're already making a lot of optimizations to make it cheaper. Do you feel like you're going to have to keep doing this for the foreseeable future? Just as, it gets better and better, you guys can get cheaper and cheaper, and eventually other people will catch up.
Other people will probably catch up to a lot of this. And people are making, Search.io, has explained how that was acquired by Algolia. They had a different type of optimization that they had, one that generally results in lower query quality. So we didn't really want to trade those things off, especially when the value prop is really high query going into generative. Costs are going to come down. I mean, you see all these Amazon's Inferentia V2 chips just came out. Those are pretty cheap to host things on. There are ways of driving the cost down, and I'm sure that they will continue to drive down. Our pricing model, I think whether we go up or down, I think we'll always want to offer a free offering to users. I think 15,000 is pretty generous, and we'll try and keep that up for as long as we can. Right now, we're not at risk of suffering from a business side. I think the bigger question is actually on all the enterprise features that we offer for what we call our scale accounts, which is more like an enterprise account. And in some cases, we might want to actually increase the price there, because I think the value that we're delivering to customers is significantly higher than what the market affords at similar prices.
Yeah, pricing's a tough one to get right. Like, we've seen the Unity stuff happening. I don't know if people have been following that, but Unity Game Engine changed their pricing model, and they're dealing with a massive developer revolt right now.
Well, they just hired the former Red Hat CEO, Jim Whitehurst.
Is that who they hired? Okay.
Yeah, he obviously, once IBM bought Red Hat, he wasn't needed anymore. So
yeah,
he's the new Unity CEO.
Huh, that's an interesting choice.
He knows communities and he knows developers, so it makes sense. Should we wrap it up?
I think we should wrap it up.
All right. Hey, Shane, thanks for coming on today. I think that the search topic is so interesting because it's so core to everything we do on the internet every day, and it's one of those things that most people don't really think about how it works. Right? They know they can just go to Google and search something and mostly get what they want back or whatever. And to talk about how this stuff is actually implemented underneath and It's an interesting look behind the covers into some technology that people don't think about. And then, of course, the same with AI. That's a very sexy topic, and understanding how that works is interesting, and thinking about the intersection of those two things. So I want to thank you for coming on today and giving us this, I think, unique insight. I mean, I definitely learned a few things. Steve, I hope you did too.
Yeah, thanks for having me on. And like I said, fantastic questions, and look forward to chatting a little bit more in the future.
We have a crack team of research interns that do all this stuff for us. Not really. Steve and I do it. We'd get on the phone at midnight the night before and go, what are we going to talk about?
That's right.
Well, if you guys like this episode, share it out, please, on LinkedIn. That's our primary audience, of course, for business podcasts here. And we'll hope to see you on the next episode. Thank you very much.
Thanks, everybody. Thanks, Shane. See you.